Hello everyone, I hope you're doing well today. Today we're going to start talking about graphing simple rational functions. So let's start off by defining a rational function. A rational function is a function in the form of f of x equals p of x divided by q of x, where p of x and q of x are polynomials and q of x is not equal to 0. Please take a moment to pause this video and record the definition. The parent rational function is the function f of x equals 1 over x. The shape that a rational function makes when graphed is called a hyperbola, which is just a graph with two symmetrical parts called branches. Please take a moment to pause this video and write down those two definitions and sketch an example of a graph of a hyperbola. The graph that you see is the parent rational function f of x equals 1 over x. Our last definition is asymptote, which is a line that the function approaches but never touches or crosses. If you look at the parent function, the x and y axis are both asymptotes. The two branches are getting very, very close to the axes, but they never touch or cross the axes, which means that our x value and our y value can never equal 0. Take a moment to pause this video and make sure you have all the definitions recorded in your notes. The first form of a rational function that we're going to learn to graph is when it's in the form of f of x equals a over the quantity of x minus h plus k. We have 3 simple steps to do this. The first is to draw the asymptotes. Our vertical asymptote is the line x equals h. Looking at our example, we see x plus 2 where our x minus h is. Since it's plus 2, it means I was subtracting a negative, which turned to the addition. So my vertical asymptote is the line x equals negative 2. So I'm going to go to negative 2 on my x-axis and draw my vertical line. My next step is to find my horizontal asymptote, which is the equation y equals k. K is the constant subtracted at the end of our equation, so we have y equals negative 1. So I'll go to negative 1 on my y-axis and draw in my horizontal asymptote. Our second step is to find and plot several points to the left and right of the vertical asymptote. So looking at my vertical asymptote, x equals negative 2. If I pick 3 values to the left, I would pick negative 3, negative 4, and negative 5. When I substitute those values into my function, I find that I get the points negative 5, 1/3, negative 4, 2, and negative 3, 3. So take a minute to plot those points. Now I'm going to choose 3 values to the right of my asymptote. So I'm going to plug in the values of negative 1, 0, and 1. When I plug those values into my function, I get the points negative 1, negative 5, zero, negative 3, and 1, negative 7/3. Our final step is to draw the 2 branches of the hyperbola. Once you've done that, you have graphed the entire function. When we're graphing them, we can connect our points and remember to draw the branches getting closer and closer to the asymptote, but never touching or crossing the asymptotes. And that's how you graph a rational function in the form of f of x equals a over the quantity of x minus h plus k. Take a moment to pause this video and record the entire example in your notes. The final form of a rational function that we're going to learn to graph in today is the form of f of x equals the quantity of ax plus b divided by the quantity of cx plus d. Our steps are very similar to the last form that we learned to graph, except our vertical and horizontal asymptotes are found differently. To find our vertical asymptote, it's going to be the equation x equals negative d over c. Looking at our equation, our value for d is negative 3. Negative 3 makes it positive 3. When I take my positive 3 and I divide it by the value of c, 1, I get the vertical asymptote x equals 3. So I'm going to go to 3 on my x-axis and draw in my vertical asymptote. To find the horizontal asymptote, it's going to be the equation y equals a over c. My value of a is 2, my value of c is 1. 2 over 1 is just 2, so my horizontal asymptote is the line y equals 2. So I'm going to go to my y-axis to 2 and draw in my vertical asymptote. My second step remains the same. Find and plot several points to the left and right of the vertical asymptote. 3 values that are to the left of my asymptote 3 are 0, 1, and 2. So I'm going to take those values and plug them into my function, and I would get the following 3 points. 0, negative 1/3. My third and final step is to draw the branches of my hyperbola. Remember as you're drawing your branches to make them go close to but never touch or cross your asymptotes. Once you have drawn the 2 branches, you have finished drawing your hyperbola and you are done graphing the rational function. Take a moment to pause the video, record this example in your notes, and I will see you in the Zoom meeting shortly. Remember to also write down any questions that you may have so we can discuss them in our meeting.